Hi friends, this is Audi1 and you're watching part 23rd of the Sqli-labs series. In the previous part, we had discussed how impedance mismatch can lead to a complete SQL injection. There we had discussed that a technology being used at the WAF and the technology being used at the backend. If the WAF doesn't understand the technology being used at the backend, could lead to a complete SQL injection or a complete bypass of the WAF. Same way, in today's lesson, we are going to discuss bypassing of some custom filters within the application and bypassing certain functions like addslashes and MySQL real escape string, and we'll discuss certain conditions when this can happen. For this purpose, I have added up 5 new modules to the test bed. So I would strongly recommend that you go back to GitHub and download the latest modules. Let's continue. For the purpose, I have updated the test bed somewhat. So added up a second page because the first page just showed till lesson 22. So you have a page 2 where it shows now till lesson number 37. Before we continue, let's go back and reset the database once. Once this is done, let's go to page 2 and see. We have 5 new modules, lesson 32, that is bypass custom filter, some adding slashes to the dangerous queries. Then we have addslashes, the inbuilt function available in PHP. We'll use some post variation of that. Then why do we even consider of having slashes when it's an integer based or something else? Lesson 36, we discuss bypassing MySQL real escape string, and that's all. So let's continue. For this, I'll be using lesson 32 and 33 for the demonstration. As you see, it's the similar application that we have used in the past. So ID equals 1 displays the first entry, second entry, third entry, fourth entry, and so on. So we enumerate. We know that there are either 13 or 14 entries in the database. From our previous experience. But if you see below, as a hint, I have also mentioned how the query that we do or how the string we sent in gets escaped for the dangerous characters. Let's try to fuzz it. Let's try to put a single quotes, and single quotes gets escaped with a backslash. Let's try to put another quote extra here and it gets escaped again. Let's try to put a slash and a slash gets escaped with another slash. Let's try to put 2 slashes and it again gets escaped. Below, you see this as the hex representation of the bytes or the characters. So how are we going to bypass this? Or first, let's go back and check the source code. I have already opened it up. So we have a function which has a name check addslashes. It inputs a string and then it uses an inbuilt function which does some regular expressions to match the slash. When the slash matches, escape it with double slash. Same way we say if there is a single quotes, escape it with a slash and the quote. If there is a double quote, then escape it with a slash and a double quote. And this is the same behavior we see with the application. If I try to put a double quotes, it gets escaped with a slash. So how can we bypass this? For custom filters, it's still easy, because while making the filters, because they are more on the purpose of blacklist, or they are just doing the blacklist approach, where they are filtering just specific bad characters. So there could be chances where it is easy to bypass them. But in our case, let's just focus on that there are three bad characters: a single quotes, a double quotes, and a slash. And to get the injection going, we need to have one quote working. So we have to escape the string boundary somehow, so that we can execute the code. So how does this happen? Going back again here, you see that the preg replace function, it parses the string character by character and checks for this character, that is the slash, and if it finds that backslash, it escapes it. Or if it parses the string for the single quotes, if it finds it, it escapes it. So how can we actually bypass this? Well, a simple answer is we can use different forms of encoding to do this. Let's see it in action. For the purpose, I am using an online encoder and decoder to encode different strings in a different format. Let's encode a single slash, and we see the different outputs. In UTF-7, it's again a single quotes. In UTF-8, that's what the ASCII characters are. It's again a single quote. In UTF-16, it is some weird character. Let's just copy it and let's just paste it here. And we see something. We see our friendly neighborhood MySQL error, and that is interesting. Now let's try to fix the query, and the query gets fixed. Let's try to add something else to it. And it works. And let's try to do order by. Let's use 4, because we know that by default there are 3 columns in the database. We have been enumerating this since module 1, so we know that. So we can encache on that information, and we can just say union select 1, 2, 3, and you see 2 and 3 on the page. And the other parts remain the same. So we get the database name. If we say user, we'll get the username. We get the user. If we say data dir, we are going to get at data dir. We are going to get where MySQL is. That's not important. The important factor is how does the filter get escaped. Well, to understand this, we can take the example of the impedance mismatch, where we saw that if we injected id equals something and id equals something, Based on the behavior of the technology, it would evaluate either the first one or the second one, and it bypassed the complete query. Same way, in this case, we are manipulating the same behavior. Here, this function, which is using a regular expression, is just matching character by character, and it's just looking for if there is a valid character found. If found, escape it. Simple. But when we encode it in a different format, what changes then? Let's do a small thing on the notepad. When we put a single quotes, it gets escaped as a slash quotes. When we put a slash, it gets escaped as a slash. Sorry, a slash and a slash. When we put a double quotes, it gets escaped as. So what changes? Well, to understand the different encodings, let me take you through different types of languages we have. For example, let's consult an ASCII table, which generally gives the UTF-8 format standard. So in here, these are the normal valid characters, starting from a 0, or let's say we are more familiar with the character format, so we just see ABC. We start with 0, ABC, 1, 2, 3, 4, and so on. Like the quotes we see here is in hex as value 27, and so forth. So if you see, we start with the hex value of 0 and go to the value of 7F. Now, in the world, we have different languages, and this is not the complete character set being used with those languages. Like Chinese is world's language which uses the most characters. So effectively, within this byte length, all the Chinese characters cannot fit in. Therefore, to represent the complete Chinese characters, we may need more than one digit, sometimes also called as multibytes. So rather than having just a single byte to represent a character, we may need two characters or maybe more than two characters to represent it. So if you see on the encoder decoder, I just used the UTF-16. That means it uses 2 bytes. UTF-32, 32 bits or 4 bytes. We can even try to use this one, and let's check this out. So it also works. But why is this working? The question is this. So to give you an explanation, I'll try to explain you in an easy way. So as discussed, we just encoded a slash in UTF-16 format. So what does it make this? Let's check. It makes it some kind of a weird character and a quotes. But for the sake or the simplicity, let's just check it here. We just added two characters which got represented as something. Let me explain on the whiteboard. Now when we are injecting some multibytes, that means a single digit would be represented with two characters. Let's say, for example, for the sake of simplicity, I'll be using just the ASCII format of saying, but I'll use parenthesis to just tell you that it is a single byte, single character, but represented by 2 bytes. Let's say A and S in the parenthesis represent one character or one unit. So this goes through the filter. The filter sees it as that, oh, A is something else and S is something else. So rather than treating this multibyte as a multibyte, it treats it as two single digits, and based on that input it parses and it injects something. So in this case, to give a better idea, let's say we inject a multibyte. I'll be using the hex. So we input BF27, the standard examples that are available on the internet. Though this is not a valid multibyte in certain encodings, but let's use it, BF27. Now when it passes through the filter, it sees BF as one character. Mind it, this is a hex representation, so 2 digits represent 1 byte. So when it passes, it sees, oh, there are two different characters coming. One is BF. Okay, BF is not in my valid list, so it goes through as BF. Then comes 27. 27 is a quote, so quote is in my list, so I have to escape it. So I'll just use the escape button, the escape sequence, that is a slash, and I'll put 27 back. So it becomes like this. Let's test it out. We'll use the URL encoding. So any hex digits we want to input, we can put them with a percentage sign. So percentage BF, percentage 27. We have the same result, we get bypassed. But down below, if you see in the hex representation, we see BF, our byte that we injected. Then we have 5C, 5C standing for the backslash, the hex representation, and 27. Let's check out here on the ASCII table the backslash. Where do we have the backslash? This is the forward slash, and here is the backslash. So the backslash is 5C, and this is what we get here. So what is effectively happening? Though we injected a multibyte, but the application just saw this as 2 units or 2 units of single bytes. So based on that feature, it says BF, okay, it's not in the list, passed. Then we have 27, so okay, 27 is in the list, so I have to inject a slash. So let me just, instead of using a slash, let me use 5C, the representation. So it becomes like this. Now this escape sequence is passed to the backend MySQL, which is configured or maybe working to accept multi-byte characters. So in this case, it assumes and it represents or uses or understands the valid multi-bytes. So BF5C being a valid multi-byte. So it says, okay, the first digit is a multi-byte, So I'll use the two blocks as a single digit, BF5C, 1 unit, and then remaining part is standalone. So this 27 is no more escaped and is just being used as a quote. So effectively this gets off and we are remained with just a standard quote which we wanted to inject, thereby bypassing the filter. Let's take another example. Rather than BF, let's use an AF. Again the same thing. AF5C being a valid multibyte, being accepted by the backend MySQL server, and 27 remains a standalone, so thereby causing the injection. And thereafter anything else you put in union select 1 2 3 hyphen percentage, and it works. So I hope you understood till now. Let's take lesson number 33 for this. Again we'll use id equals 1, and let's open up the source code for lesson 33. So in here we are using the function of addslashes. So we say we just input a string, we pass it through the addslashes, and we return the value, and then this is being used within the query down below. Let's try this out as well. We put a slash, it's get escaped. We put a quote, it gets escaped. We put double quote, it gets escaped, and henceforth. But this again suffers from the same problem. The application itself, when it takes the input, it takes the string as UTF-8 and it parses each character individually. But when it goes to the backend parses the string differently, different from how it was passed by the application, thereby causing an issue with the encodings mismatch and causing the SQL injection to happen. Let's see. %AF %27, and again we get the MySQL error. That means we effectively bypassed the filter. Union select 1 2 3 hyphen plus, and there we go. And let's use database. I'm not going forward and enumerating or extracting the complete database, but take that as an exercise and you can proceed forward. Well, this is all for this video. I hope it was intuitive. Please leave your feedback in the feedback section. Thank you very much and happy watching.